Assalamualaikum warahmatullahi wabarakatuh. Welcome to another short video on 01 knapsack problem. What on earth is 01 knapsack problem? I've never heard of a name that starts with numbers. Well, 01 kinda means you either take or you don't take. So no, that doesn't make any sense. Let's go to a problem, straight to a problem, and the approach we're taking is dynamic programming approach. So the color I will choose today is blue. So you have four stuff. Number one, some items, their weight, how many items do you have, and what is the total allowed weight. These are the four things that you have. So what I did is, first we draw a table. By the way, this is the point of 0, 1. You cannot have fractions. You either take or you don't take. So we draw a table. We start with 0. Some tables don't start with 0, but I started with 0 because we'll see the benefit later. So 1, 2, 3, 4, 5, 6, 7, 8. Why 8? Because that's the total allowed weight. I cannot have more than that. And 0, 1, 2, 3, 4. These are the numbers of items that I am allowed to use. These are the weights of my numbers, and you already know that's over here, W, 2, 3, 4, 5, and these are the stuff, and that's this A. Clear them out. So now we'll start. How do we do this? First things first, we fill up zeros. 0, 0, 0, 0, 0 again, 0 for life, and 0 rules again. Anyways, that we're done. And now for 1, I'm going to put something. What am I going to put? Look at the weight at 2. So at 2, I will have 1. So at 2, I will have 1. Now what will I put here? 0, which is the previous number, and there is nothing more to consider over here, so I will keep all the others as 1. Now this time we will consider 2 of them. So first let's go with 3. For 3 we'll have 2. Okay, 3 will have 2. I'm cool. And 3 plus 2 is 5, and 2 plus 1 is 3. 5 will have 3, so 5 will have 3. Now you know what to do. Put the rest as 3 since there is no more. And what will this be, guys? What did we do? The previous one, so 2, and this 1, and this one will be 0. Okay, cool. Now we'll have to consider 3 of them. So first 4 will get 5. I'm cool with it. Then 4, 5, 6, 7. 7 will get 5, 6, 7. 7. So 7 will get 7. Then 4, 5, 6, 7, 8, 9. 9 doesn't exist, so that's a no. So now I have to fool it with this. Now 4 plus 2 is 6. 6 will get 6. This and this 2. 6 will get 6. Now all we need to do is fill up the rest. So this will get 7. This will get 5. And these will get 2, 1, 0. I hope I'm doing it right. And then we have the last one. So 5 plus 4, 9. That's a no. 5 plus 3 is 8. Okay, 8 will have 8. So 8 will have 8. That's our first. 5 plus 2 is 6. 6 will have, no, 5 plus 2 is 7, sorry. 5 plus 2 is 7, and 7 will have 7. We already have that though. Then 5 plus 3 is 8. We did that. 5 plus 4 is not allowed. Okay, so we are done. Now here we go. Now we need to draw some extra things. So we have 4 items here, right? So I will draw item 1, you know what, item 1, item 2, item 3, and item 4. You can call them x1, it's okay, the same thing. Now let's see which is the largest. 8. We find 8 at item 4. Is 8 on item 3? No. So 4 will get 1. We'll take 1 from 4. And the weight and the profit, benefit, whatever you call it, is 6. So we subtract 6 from 8. And then we get 2. So we look for 2 on 3. Do we have first on 4? We have 2 and 4, yeah. Do we have 2 on 3? Yeah. Do we have 2 on 2? Yes, also. So we have to ignore 3 because we have it on 2. Do we have it on 1? No. That means 2. So 2 will get 1. And then the value is on this item 2 is 2. And so 2 minus 2 will be 0. So the next item we'll be looking for is 0. And you find 0 on 4, yeah. On 3, yeah. On 2, yeah. On 1, yeah. On 0, yes. That means we cannot take 1 because it is available in the upper one. So 1 is 0, 3 is 0. So the combination is 0, 1, 0, 1. The handwriting is horrible. I hope you used my voice to understand this. So now I'll show you the answer. Here you go, and there it is, cleaner version than my Hebrew handwriting, and this is the formula. So there is another way to do this, that is called the set method. So in the set method, what we do is we start with 0, 0, and then we pick 1, 2. Where did I get 1, 2? Over here, 1, 2. Okay, then we add it to the set. 1, 2 is fine, and then S1 and 1. What do we get? 2, 3. And then we add it to the set. So if you add 2, 3 to 1, 2, first we'll have to add 2, 3 to 0, 0. Then we get 2, 3. And then we add 2, 3 to 1, 2. Then we get 3, 5. 2 plus 1, 3. 3 plus 2, 5. Then we have 5, 4. So we have to add 5, 4 to this combination. So first we get 5, 4. Second we get 6 and 6. 6 and 6, yeah. Then we get 7 and 7. Yeah, cool. And then we get 8 and 9. Okay. But 8 and 9 is invalid. Why is it invalid? 9. I cannot have a 9 here. Limit is 8. So 9 is a no-go. So it is rejected. 8, 9 is invalid. And now we add this combination, and then we'll have to add 6 and 5 to all of them. So by adding 6 and 5, let me bring out my pen, we get 6, 5, 7, 7, 8, 8, 11, 9 invalid, 12, 11 invalid, 13, 12 invalid, and that's all. And we got an invalid one over here. Now why did I put out 3, 5? 3, 5 is valid. Except notice that here it is increasing. 0 to 2 and 0 to 1, 1 to 2, 2 to 3, 2 to 3, 3 to 5, okay, but 3 to 5, 5 to 4, it's decreasing. That's a problem. I can't have that, so I'll have to get rid of him. Now I can see 2 to 5 and 3 to 4, cool, and 5 to 6, 4 to 6, and 7, that's okay. So by getting rid of this is the dominance rule. So and then later we remove the invalid ones, and finally we end up getting this set. Now what do we do this with set? I'll explain this. This is very similar to the tabular one. So 8, 8, huh? That's the biggest one. Does that belong to set 4? Yeah, it does. And it does not belong to set 3. So you put F1 on x4. And then you subtract the final value, which was 6, 5. 6 from 8 and 5 from 8. Since both of them are 8. This is the P and this is the W. And then, which is also, you can say, A and W. Then we get 2, 3. Does that belong to S3? Yeah, but it also belongs to S2. Let's look. I have to get rid of the drawing. 2, 3 belongs to S2 as well over here. So that means I cannot take S3. So S3 is gone and we have S2. And that's why we have 1 on S2. And then subtract 2, 3 from it. And then we get 0, 0. So we find 0, 0 on 0 also. So we cannot take 1, similar to the tabular one. And the final combination is 0, 1, 0, 1. Probably the quickest video on Knapsack problem. If you have any problems, let me know in the comment section below. And thank you for watching. Peace be upon you. And happy